Photographers, going to go over your second lab activity and just I'm going to kind of just quickly go through the lab thing itself and point out some things what I expect you to do. I'll talk a little bit about latitude and longitude since if you're taking the lecture class as well, you haven't heard me talk about that stuff in that class, so it may be kind of new to you. But what I will say with these labs, as you're going through them, make sure that you are, in fact, reading this stuff. I think I mentioned this the first time that we interacted on that Zoom meeting, but do make sure you read through the stuff that's written here. And if you don't get it right off the bat, or if something isn't, clicking, go ahead and read it again, right? And work through it to try to make sure that it's clicking in your brain. And I say that, the read it again thing. Be aware that in academia, in college, that's what you're gonna have to do for a lot of this stuff if it's not clicking right off the bat. And this is something that is just this is how it works. A lot of the stuff I read as I'm, trying to learn new things, doing some research or whatever. There is nothing that I read and read it, the first time and I get it and it all makes perfect sense. Just doesn't work that way, right? If you do find something like that, it turns out, oh, you're not actually doing much learning in that sense. So just be aware of that. That as you're going through here, and I try to make this stuff as simple and straightforward as possible, but just keep in mind that you're going to have to work a little bit to even try to begin to get what it is you're supposed to do. Now that said, of course, I'm going to walk you through some of the stuff, help guide you through some of these things here. But still, don't take this video as all you need to do. Read all of this stuff. In many cases, the answers you're looking for are going to be in this text here. Also, be aware this is going to go along with a lot of the stuff you cover in the lecture class. So if you're currently taking it, if you're in the like the lecture class with me, you've got the readings, the textbook there. You've got the lectures. You're going to be exposed to some of this material in other ways. But like, go ahead. If this lat long stuff isn't clicking, read that second chapter of the textbook to help get a sense of what it actually is, what's going on there. I'll also have that lecture on geodesy posted in that class. It's set for like next week, but I'm going to try to get that by the end of this week, have that recorded and done, so you'll be able to listen to that. And some of this might also help to make sense. So those are your resources there. But with latitude and longitude, really all this is, it's a grid. Okay? It's a grid system and what we call a coordinate system, meaning that it's designed to help us find either where we are or where we want to go, right? And that's all it is. So it's this grid that we use for location. Now, latitude refers to these horizontal lines. So if we're looking at it, this is the globe right here. And this image on the left, the latitude is running horizontally or east to west, right? But it measures north and south, okay? And that's kind of wacky. And that's another thing that you need to be, working through here is just figuring out a way to envision exactly what the differences are between these things and be able to put it into your own words so it works in your brain, right? So latitude, horizontal lines, so they run. So if this is north up here, this is south down here, right? We've got east over here and west over there. So it's running from west to east or east to west. That's how these lines are drawn. Okay? That's what I mean by running here. And we start at the equator, which is just the midpoint, in between the North Pole and the South Pole. And so that's 0 degrees. And then we just start counting up 1 degree to the north, 2 degrees to the north, and so on. And we do the same thing in the opposite direction. And so we have 1 degree south, 2 degrees south, and so on. Okay? And the North Pole is going to have a latitude of 90 degrees north. That's the maximum number you can have for north latitude. And the South Pole is going to be 90 degrees south. Okay? So your latitude values are always going to be somewhere in between 0 and 90, and they're always going to have an N for north or an S for south at the end of them. Okay? So it's telling you how far north or south you are from the equator. Hopefully that makes sense. Now longitude, these lines run in the opposite direction. Okay, so they're vertical right here, right? Meaning they run from north to south, but they're going to measure east or west. Right? And we start with the prime meridian, so that gets a value of 0 degrees as well. And this one, it's kind of an arbitrary place. It runs through Greenwich, England. It's spelled like Greenwich, but it's pronounced Greenwich because the Brits. That's how it works. But it runs through there. So and Greenwich is like a suburb outside of London, if you want to think of it that way. So that's our 0 degrees running there, and then we go 1 degree east, 2 degrees east, 3 degrees east, and so on, and we go 1 degrees west, 2 degrees west, and so on. And they meet on the other side at the international date line, which is technically at 180 degrees longitude. Okay, so all of your longitude values are going to be between 0 and 180, and they're either going to have an E for east or a W for west. Okay, and then for this to work, you need to have a latitude value and a longitude value. Because if I say I'm at 45 degrees north and that's it, well, that's not that helpful. I know I'm at this latitude, but I don't know exactly where I am along that line. I could be anywhere around this whole line of latitude around the entire globe. All right, but if I have a line of longitude as well, say I'm at 45 degrees north and 45 degrees west, I can see where these lines interact or intersect, right? And where those two lines intersect, that's my exact location, or that's the location of the place I want to go to, or whatever. Right? So I have these things, they're separated here, so you can get the distinction between latitude versus longitude. But when we're dealing with this stuff, we're using them together, right? We need two of these values. We need that latitude and we need that longitude to know exactly that precise location. So that's what latitude and longitude is. And again, read through here. There's more information, and like I said, read through the second chapter of your textbook. You can also, there's nothing wrong with going online, hitting YouTube or whatever, for any of this stuff. Now, there's always the chance that it'll make you more confused. It won't be discussing exactly what you need it to discuss or whatever, but that it's a resource. Feel free to do that. And of course, after this explanation and you watch this video and you work through it, if something's still bothering you, of course, contact me as well, and we'll work through it. All right, but hopefully this makes sense there. Now, as you go through this lab, read through all of this, and then just pay attention as you're going through. All of the things you need to answer or do should be numbered here. Okay, so like number 1 and number 2 here, they're referring to this, and it's getting you thinking about this stuff like as a grid and comparing it to an algebraic grid, which most of you hopefully have dealt with. This is a different concept, kind of, but it's a grid. So in a way to try to get you guys kind of connecting it to what you've learned in math classes to what you're doing here. These are just a few questions about, positive and negative values, right? So remember, when you're mapping stuff on an XY axis, and on one side of the axis it's going to be negative, the other side it's going to be positive. This is getting you to think about these latitude and longitude values in that way, which we're not going to deal with that much, honestly, in here, but it becomes useful later when you start to do this stuff with computers, and it helps you down the road if you are to continue to do this stuff. I know most of you won't continue to do this stuff, but just do the best you can here. I'll also say when I'm grading these things, I'm not going through every single thing and carefully grading every single answer. In here, I've got, it's worth 10 points. And I've got certain areas that I know are more challenging, and therefore those are the ones I'm going to be looking at, right? To see if you really, you know, put forth some effort, right? So it's my way of saying, like, don't get hung up on this stuff. Still do it. Try to do something, but don't kill yourself on all of this stuff. It's as you continue down, you're going to get into the more important things. All right. So as you continue to move through, you finish this stuff, move on to this section 2.3. Of course, read through all this stuff because it's going to have like, yeah, right here for 6, it says using the above coordinates for Los Angeles, plot a point showing where it is on figure 2.3, which is this right here. And you'll know the coordinates for Los Angeles because you read them right here. For example, Los Angeles, California is located at 34 degrees, 3 minutes, 0 seconds north, and 118 degrees, 15 minutes, 0 degrees west. All right, and so you're going to take those coordinates and draw them where they go on here. All right, so to look at this, we've got this line going this way horizontally, right, or running from east to west. That's going to be latitude, right? So this value of 35 degrees here, that's latitude. 34 degrees, another line of latitude, and then 33 degrees, and we see the north right here, so that's latitude. Right, so those are our lines going horizontally. It's got to be latitude. And then our two vertical lines, we have 119 degrees and 0 minutes. And the degrees and minutes, it's explaining that in here. I'll be talking about that with that geodesy lecture, and it's in the textbook and all of that. So hopefully that'll make sense. So we've got the 119 degrees longitude, 118 degrees west longitude there. So for 3 through 6, you're simply drawing lines for 3, 4, and 5. So based on this, where should 118 degrees, 30 minutes west be drawn? All right, so you're going to draw a new line of longitude in here. Okay, and then for 6, you're going to actually be putting in a point because you have both longitude and latitude, right, for Los Angeles. So you can figure out, again, think about, where this would be 118 degrees, 15 minutes, using what you've read here and what you're figuring out. Figure out where would that line of longitude be for LA, and you can do a little temporary line there, and then figure out where this 34 degrees, 3 minutes north is going to be, and then draw a line there, right? And where those two lines intersect, that's where LA is on this particular map. And also, don't kill yourself like with the 3 minutes. Doing this 15 minutes should be pretty easy. If you figure it out as you're reading through there, you should have a pretty good sense of where it should be on the map. The 3 minutes for the latitude value here, it's a little fuzzier. Just do the best you can. I'm not going to have a ruler out and be, measuring this stuff out. Just do what you can do there and, again, put forth some effort. Okay, so you're just drawing lines, or in the case of LA here, you're putting in a point. Okay, so that's how that's going to work. Down here, focusing on latitude. Read through here. We've got, this is the idea of if the Earth was cut in half, you have the equator running here, or North Pole or South Pole, this point here in the center of the Earth. Things like draw a line from the North Pole to the center of the Earth, right? And so you're going to go from the north to the center right here. What is the angle? So you need to measure the angle between this new line and the equator right here to get a sense of, what is that angle? And that will, connect to some stuff here, right? Same thing with the South Pole right there. Draw a line at a 23.5 degree angle from the center to the northern hemisphere. Um, this is the protractor thing, which I said you guys are going to need to have. Hold that protractor here at the center and just draw a line to the northern hemisphere at a 23.5 degree angle. Okay, and then draw that in. Great, and then it's has this question: what is significant about that location? Try to figure it out. Look, in your textbook, look online, and so on. But 23 degrees north, um, that has significance. So that should be relatively easy to figure out. Okay, so that's how that works. Now we're getting into the good stuff right here with 11, and this, as I said, it's geared toward that Essential World Atlas by, from Oxford. So use that if you got it. Anything else will work. I know we just started, and I know like shipping and stuff like that is crazy. So if you don't have this now, do the best you can. Look online. Try to find a map like for here, Medford, Oregon. Okay, we're looking up, Oregon in the U.S. That state right here, a city in that state. Find a map, something that isn't Google Maps. Try to find a picture map of the Western United States or Oregon or whatever that has latitude and longitude. And then what I want you to do is estimate. Try to figure out what is the latitude, degree, and the minute, if you can figure that out, for Medford. Don't even need to worry about longitude right now. Just try to figure out latitude for this one. Okay? Once you've estimated that as best you can, look it up. Figure out what is the exact latitude to the minute for Medford. And if you have the atlas, so I've got the page number right here, you would see the map, and then you can look in the index and it'll tell you exactly what it is. So for all of these different, Shenyang and Tbilisi and all these other world cities here, do that same process. Okay? This one here, these cities, and there's kind of a clue with these, like, cities near the 42nd parallel, near the 32nd parallel. That gives you a general sense of what your answer should be close to. But same thing here. Okay, in the southern hemisphere, we've got Argentina, Australia, South Africa. Find these cities, find the maps, estimate the stuff, and then look up the exact thing. Okay, and then longitude, same deal. Other cities doing the exact same thing, but now you're doing it with longitude. And then as you scroll down this 2.6, test yourself. Try to put a definition for latitude and a definition for longitude in your own words right here. And with all of this stuff, look, it's not going to be that hard for you guys to cheat. You could just look it up. You could, Google stuff. Same thing with all this stuff right here. Yeah, I can't stop you guys from just, looking stuff up and not really trying. But, just one thing to think about is if you are, in fact, taking that lecture class with me, you're going to be tested on latitude and longitude with our first exam. And so this is a good opportunity for you to start studying and to start learning this stuff so that when you're faced with all sorts of questions about latitude and longitude on that exam, you have some background here, right? So really take this stuff seriously. Make the most of this so that other class, which honestly is going to be a lot harder than this lab class, take the time now so that it'll work for you, right? So just put it in to your own words as best you can. If you need to refer to stuff, fine. But think of this as more of a study aid rather than you're being tested here yourself right now. Okay? All right. Now down here, you have this map of North America-ish right here, mainly the US is what we're looking at. And I've got drawn on here these lines of latitude and lines of longitude. And then I've listed here 5 US cities. What you need to do is look up the latitude and longitude for Lafayette, Louisiana, for Houston, Texas, for Detroit, Michigan, all these cities that we have here. And what would be the easiest way to do it is write that out next to like Lafayette, write their latitude and longitude. Okay, right there. And then on this map, look at the, read what's here. 30 degrees north. That's going to be this line right here. And so this is 40 degrees north. That one's labeled. So I'm guessing you can use your powers of deduction, figure out what this value is right here, what the increments are for latitude. Same thing with longitude. Not every single line is going to be labeled here, but it should be pretty easy to figure it out. And then wherever, the latitude and longitude of this city here, say, places it on here, you're just going to put a little dot, mark a point there and label it. Either write just, 16 or Lafayette or, whatever you want to do. Okay, so we're just going to see if you can plot stuff on the map itself. And then with this last thing, so this is the very end, once you get here, got one more thing to do and you're done. With these, we're doing it in the opposite way. I'm giving you the latitude and longitude. So you have 55 degrees, 0 minutes north, and 83 degrees, 5 minutes east. You need to take that. Don't put that into Google and search it. There's no fun in that. Using an atlas or using a world map or whatever, or if you have, I don't know, you guys have globes at home? You should. God, what's the point of a home without having at least one globe in it, right? I mean, come on. Anything you have where you can use this, try to figure it out. A globe, of course, is going to be a lot harder if that's what you have. Using an atlas, a map at a much better scale for this kind of thing is going to make it easier, but do the best you can. And really, because we're not all in the same lab, we're not hanging out in the same room and using the same materials and all that, I'm not going to be too hung up on if you get the exact city. I'd rather you guys try and kind of experiment and test yourselves with this and get it a little wrong than for you to just, Google it because it's too frustrating just to make sure you get the right answer. And to be honest, a lot of these numbers, they kind of can be fuzzy. These are specific to this Essential World Atlas. So you could, just to let you know, you could plug this stuff into Google and still get the wrong answer, right? It's very possible. Or get, a few different ones depending on the level of precision that's being used. So just be aware of that. All right, so hopefully all this stuff makes sense. As I said, if it doesn't, well, first make sure, listen to this. Okay, listen to what I'm saying here as we go through it. Read through the different things in the lab, the different bits of instruction and what I'm asking you to do, right? And also refer to your textbook, to the internet, and all that stuff. Like, you've got a lot of resources here. And then if that's still not working, if you're still frustrated, if you're still having a hard time with this stuff, let me know, all right? And I'll help you out. Just make sure you're being specific. Okay? The one thing I can't stand from students is when they say, I don't get it. And I say, oh, what is it you don't get? I don't know all of it. Like I'm supposed to just kind of magically make their brains work or whatever. No, this is college, for crying out loud. You got to put forth that effort. What you should be saying is, I don't get this specific concept here or this question. I don't exactly understand what's going on, right? But you need to do the work to make sure that you're actually, trying to understand it before you ask for help, right? If that makes sense. And I'm not saying that to be a jerk and to say like, so don't talk to me. No, I'm happy to help you out, but just, you got to be putting in the work. All right. Okay, geographers, you got this. This is going to be easy. And actually, honestly, this is one of the easier ones that you're going to be doing. So, get get ready for that. The next one we do, Lab 3, that's a doozy. That's one that students love. So yeah, enjoy this one now and get ready for next week when we have some really hardcore geography that we're doing. All right, folks, enjoy.